Have you ever wondered how the small power-packed batteries that fuel your gadgets came into existence? Let's take a leap back in time and discover their fascinating origins. Picture this. It's around 200 BC, and we're in the bustling city of Baghdad. An artifact known as the Baghdad Battery is created. This rudimentary battery, believed by some to be the first of its kind, consisted of a clay pot, a copper tube, and an iron rod. While the exact purpose of this invention remains a mystery, it's a testament to the early human ingenuity in harnessing electricity. Fast forward to the year 1800. In the scenic landscapes of Italy, a physicist named Alessandro Volta is about to make a groundbreaking discovery. He invents the voltaic pile, the first true battery. It was a stack of alternating layers of zinc, blotting paper soaked in salt water, and silver. This invention could produce a reliable, steady current of electricity. Volta's creation ignited the spark for the use of batteries, transforming the world of science and technology. However, there was one crucial limitation. Once the chemical reactions inside these batteries were spent, they couldn't be reused. This problem was solved almost 60 years later by a French scientist named Gaston Plante. In 1859, Plante invented the first rechargeable battery, the lead-acid battery. This was a game-changer. Not only could this battery be used multiple times, but it also paved the way for the development of portable electronics. And so began the journey of batteries, powered by human curiosity and the need for portable energy. The stage was set for the evolution of batteries, from the humble beginnings of the Baghdad battery through the voltaic pile to the first rechargeable battery. Each step of this journey has been a testament to our relentless pursuit of innovation and progress. So the next time you charge your phone or switch on your laptop, remember the centuries of discoveries and inventions that make it all possible. As the world began to shrink, the need for portable power increased. Enter alkaline batteries. The 1950s were a time of innovation and advancement, with one such development being the creation of alkaline batteries by Louis Urey. Urey, a Canadian engineer working for the Eveready Battery Company, sought to improve upon the existing zinc-carbon batteries that were common at the time. Alkaline batteries gained popularity rapidly, and for good reason. They offered a long shelf life, often years longer than their zinc-carbon counterparts, which made them ideal for use in devices that required infrequent battery changes. In addition, these batteries delivered superior performance. They could provide a steady flow of power for longer periods, making them the perfect choice for power-hungry devices like toys, flashlights, and radios. However, as these batteries became ubiquitous, concerns began to arise over their environmental impact. Unlike the rechargeable batteries that would follow, alkaline batteries were designed to be used once and then discarded. This disposable nature led to a significant amount of waste. Each year, billions of these batteries ended up in landfills, where their corrosive contents could potentially seep into the ground and contaminate water sources. Efforts were made to recycle these batteries, but the process was complex and expensive. As a result, only a small fraction of alkaline batteries were recycled, with the majority ending up as waste. This issue highlighted the need for a more sustainable solution in the form of rechargeable batteries, which we'll delve into in the next segment. Alkaline batteries, for all their advantages, had a significant downside. They revolutionized our gadgets, providing us with the portable power that our increasingly mobile lifestyles demanded. But this revolution came at a cost to our environment. It was a lesson in the need for balance, a push and pull between progress and preservation. It's a lesson that continues to shape the development of batteries even today. With growing environmental consciousness, the world needed a solution. The answer lay in rechargeable batteries. Enter the nickel-cadmium, or NiCd batteries. Born in the mid-20th century, these little powerhouses offered a new, reusable source of energy. They were the first rechargeable batteries to gain significant commercial traction. With their ability to be recharged hundreds of times, they certainly had their advantages. However, they weren't without their drawbacks. Cadmium, a key component, is a heavy metal with environmental and health risks. Additionally, these batteries suffered from what's known as the memory effect. If they were recharged before being fully drained, they would remember the shorter cycle and lose capacity. But innovation never sleeps. Seeking a safer and more efficient alternative, the world witnessed the rise of nickel metal hydride, or NiMH, batteries. Introduced in the late 80s, these batteries address some of the shortcomings of their NiCd counterparts. They were more energy dense, meaning they could hold more power for their size, and didn't contain the harmful cadmium. However, they too had their Achilles heel. They tended to lose charge quickly when not in use. The real game changer arrived in the 90s, the lithium-ion battery. These batteries offered something truly revolutionary. They were even more energy dense than NIMH batteries and didn't suffer from the memory effect. With their lightweight nature and high energy output, they quickly became the battery of choice for many high-drain devices, including laptops and smartphones. With each evolution, rechargeable batteries became more efficient, more powerful, and more environmentally friendly. They moved from being simple power sources to becoming integral parts in the functioning of our everyday devices. From powering our remotes to keeping our phones alive, they've truly revolutionized the way we live and work. The rechargeable revolution was here, and it was here to stay. As technology advances, so does our need for even more efficient batteries. What does the future hold? Well, one word: innovation. We're pushing the boundaries of what's possible, and that's evident in the ongoing research on solid-state batteries. Imagine a world where batteries are safer, charge faster, last longer, and don't have the risk of leaking harmful chemicals. That's what solid-state batteries promise to deliver. These batteries replace the liquid or polymer electrolyte found in current lithium-ion batteries with a solid. By doing so, they can potentially store more energy and deliver it more quickly. It's like trading in your old bicycle for a sleek new motorcycle. Sure, both get you from point A to point B, but the motorcycle does it faster. And let's be honest, it's a lot cooler. Then, there's the potential of graphene batteries. Graphene is a single layer of carbon atoms arranged in a two-dimensional honeycomb lattice. It's incredibly strong, light, and an excellent conductor of heat and electricity. Now, take those properties and apply them to a battery. You get a power source that can charge incredibly fast and hold that charge for a longer period. It's like having a superhero in your pocket, ready to power your devices. Lastly, let's talk about the concept of energy harvesting. The idea is to capture the small amounts of energy that are constantly around us and put them to use. Think about the energy from your movements, the sun's rays, or even the heat from your morning coffee. Energy harvesting technologies aim to capture all that wasted energy and convert it into electricity. It could mean never having to plug in your phone again, or at least not as often. The evolution of batteries is far from over. The best, it seems, is yet to come. So buckle up, because the future of batteries is going to be an exciting ride. From ancient Baghdad to modern-day smartphones, the journey of batteries has been nothing short of remarkable. Let's take a moment to reflect on this incredible journey, a journey that started with the humble voltaic pile and now stands on the brink of a graphene revolution. The voltaic pile, a stack of alternating copper and zinc discs separated by brine-soaked cloth, gave birth to the concept of a battery. It was a scientific marvel that marked the beginning of a new era, the era of harnessing electricity. But it was not until the advent of alkaline batteries that this power truly came to the hands of the common man. Small, portable, and powerful, alkaline batteries sparked an electrical revolution, lighting up homes and powering devices, making electricity an integral part of our lives. Then came the rechargeable revolution, a revolution that made batteries more sustainable, more efficient, and more powerful. Lead-acid batteries, nickel-cadmium batteries, lithium-ion batteries, each one an evolution, each one a step towards a future where power is not just accessible but also sustainable. A future where our devices last longer, work better, and impact the environment less. And now, we stand on the brink of another revolution, a graphene revolution. Graphene batteries, with their incredible energy density and fast charging capabilities, promise to redefine what we know about power storage. They promise a future where our devices charge in minutes, not hours, where our electric cars go further, and our renewable energy systems store more. This evolution has not just changed our batteries, it has changed us. It has shaped our lives, our society, and our planet. It has made us more connected, more mobile, and more conscious of our environment. And as we stand on the brink of another revolution, we can only imagine what the future holds. As we power into the future, one thing is clear: batteries will continue to evolve, and with them, so will we.